Hi everyone, for those of you who are watching this on video, the only thing that you missed was a quick review of use substitution, which we're now applying to this.
Oh, you can't do that. Remember when you have it to muscle it? When you have it to moving, you need to do it out of the way. Oh, you can divide all the way by 2? Wait, let me show you what I mean. Like this. You have to like look, you have to like do this part. You have to do like this. Oh yeah. You can't pull it. Yeah. Wait, hold on. Yeah, because remember you have to back into like uncoil. So when you do like these to make something less. Jillian, what'd you get for you?
I didn't substitute you, I just found this here.
Yeah, but when you have the thing in front, you have to do this. Yeah, exactly. Do you know what I mean? Okay, see, she is. Oh my god, no. I got you for 1/2 and I got not for 2. I don't care. What'd you get? How did you get this? Okay. Let me show you guys. Okay, so basically, wait, so you take, you have the original problem, right? And then you have to use 2 and -1 and figure out how that added to something is 1. And so then you do 2u squared plus 2u. Minus 1 here, and then minus just the 1 here. So you put like these 2 things, and then to make the middle term, you do this, plus 2u minus u. It's like the factory thing. It's the reverse foil. Oh. Wait, no. If you have 2 plus 1x, then you have over here 2x, and then over here minus 1, and you use these terms to do plus 2x minus 1x, and it's the same thing, it's equivalent, so you can write that out. What? No, not pushing. It's like you use these 2 terms and figure out any way they can do this. Yeah, and then okay, well, it's fine. And once you have it, then you can try to pull out. So you do 2u squared plus 2u, so you pull out 2u, and you get u plus 1, and then minus u minus 1, because like you pull out -1, and that gives you u plus 1. The u is just u, I don't like the u, and then you have u equals 1 half. Oh my god, I don't get how to factor out something, so I understand it.
Yes.
Is this like, can you check if mine's on the right track?
Sure.
Did you get it? I didn't solve.
Okay, but now what do we do?
I didn't fucking do it.
I don't find actually the lane.
I
have no idea.
Hey ladies, when you get to the point where you have sine of x equals something, that's where you use the unit circle.
Oh.
Okay? So please give me exact values.
Wait. Triangle is pi over 3. Pi over 2. Okay, so 1/2 is when it's at 30 degrees or 60 degrees? Wait, when? 30. When it's 30, when it's 30. It's the y. It's 30, right? Yeah. So then right here, with pi over 6. Oh, you legitimately know. Pi over 6 goes 1/2, and then for the negative 1, for the y is here. That is 5 over 6. Is this right? 5 over 6, 3 pi over 2?
There's one more. The sign of x equals 1/2. There are two places on the unit circle where a sign is 1/2.
Pi over 6. 5 pi over 6? Miss Alon, is it 5 pi over 6? Yes. We should.
I will give you a high five in the air. Good job. Caroline, can you put away your device, please? Okay. All right, one team has answered. How's it going with everyone else? Yeah. Okay, could you hold it up on your board? You guys should get 3 answers. 3? Yes. You guys got this. Yeah, when you think you have it, hold up your board. I'll give you a thumbs up or a close or a no or something.
The height is 1/2. But then right here, the height is also 1/2. And then the third one, it's for -1. This spot is 0, -1, the sign is 0. So it's this one. Oh, okay. I understand this, but this is the only thing
Yes. Great job, ladies. So now we're waiting for teams 2, 5, and hold on. 2, 5, 6, 7. Kaylin, you have 3 shadows at your table. Do you guys just want to kind of combine? Okay. So between both tables, just one person answered. Yeah, actually, the first 2 are correct. The last one is not.
Is it?
Yes. I don't know it.
The Wi-Fi.
I think it's like OLP pilots or something like that.
Yeah. So
Yeah. Go ahead. Sorry. The third one. Let me see. I think you just flipped it. Yes. Sure. Yes. Actually, hold on. The last 2 are right. The first one is incorrect. All right, everyone's gotten... Oh, wait, have you guys answered yet? No. Almost everyone has gotten at least 2 out of 3 correct.
Oh, look, Mia, can I show your baby? Mia's an AP Science, and she has a project for Rio. I said it's like 2 weeks.
That's so funny.
So much trauma.
He showed that to me last year. I laughed so hard because she made it look like an official CPS. And he said I opened it and I panicked. I was like, "What did I do?" And then he's like, "Oh, Miss Hanley." It's because she sent an email to all faculty and staff and said, "Be on the lookout because it'll be fun."
And you get points off, right?
Yes. Yeah. All right, so now at this point, everyone has gotten at least 2 correct, so I'm going to go over the answer. All right, here we go. My bad. Okay, so u substitution, u is going to be sine of x, as we previously discussed. You plug this in, you get 2u minus 1, u plus 1 equals 0. Set each of them equal to 0, you get u equals 1/2. which means sine of x equals 1/2. There are two places on the unit circle where sine is 1/2, and that's pi over 6 and 5 pi over 6. U plus 1 equals 0, u equals -1, sine of x equals -1. There is one place on the unit circle where sine is -1, and that's at 3 pi over 2. All right, now, these are, well, I gave you guys the thumbs up for these. Those actually aren't the answers. These are the answers. And normally I would say, hey, I'll give a bonus point if someone can raise their hand and tell me why. But in this case, I will give a smile and kudos if anyone would like to raise their hand and tell me why. Yeah.
Because you could like simplify it further, because you could find them on the unit circle to where like the y point correlates that with the sine of x point.
Yes, but why can't we just say that's true? But why can't we just say this and it be correct? Because these are all correct. Yeah.
Because the equation's 2 sine squared and sine, so you need to like plug it in.
That's a good guess, but that's actually not the reason. That's a good guess, though. Yes, good observation.
They like repeat. It's like a repeating thing.
That's what we'll see. But why do we have to put the 2n pi? Why can't we just say pi x, 5 pi over 6, and 3 pi over 2? Why can't we just say that? Because those are correct answers.
Because it continues.
It does.
It's like the unit circle.
Yes. So the reason is because they didn't give us they didn't give us a domain. They didn't give us a span of numbers to work with. Sometimes it says within the restriction 0 to 2 pi or something like that, in which case you would just look for answers in that range. In this case, they didn't. Because they didn't do that, you actually have to find all possible answers. Does that make sense? Okay, so this is actually really important because this is going to be a distinction on the AP exam and on your upcoming tests. Some problems are going to give you a specific range, and some problems aren't. If it doesn't, you've got to find them all. Sine repeats itself every 2 pi. So if you add 2n pi where n is any integer, that covers everything. Do you guys remember the periods of all the other 5 trig functions? What's the period of cosine? No, the period. 2 pi. How about tangent? Pi. How about, and then cosecant, secant, and cotangent are the same as their reciprocals. So cosecant and secant have a period of 2 pi, and cotangent has a period of pi. Okay, so if you're solving something like that, that's what you would be adding. It would be n pi or 2n pi. All right. Let's take a look at example number 8. It says prove the identity here. And let me see if I can give you a hint to get started. What I would recommend here, I recommend converting everything to sines and cosines and then getting a common denominator and then seeing if you can cancel some stuff out. Okay? You don't need to write this on your whiteboards unless you want to, but when you're ready, call me over and I'll look at your proof. Please give reasons for each step. You guys got this. So again, convert everything to sines and cosines and then get a common denominator. Yes. Yep.
Well, I first did convertible. So
Okay, so here you use the quotient. Then you use the Pythagorean.
well, I just left to get
So it actually
Yeah, but I don't.
You guys help her out?
Yeah, but I think I got it.
Okay.
Yeah. Wait. Yeah.
Hey ladies, a common mistake that I'm seeing, remember that when you're doing proofs, you're not starting with both sides. You're starting with the left side, just the left side of the equal sign, and you're working at trying to achieve the right side. So ignore the secant x, cosecant x. Just work with tangent x plus cotangent x, and see if you can manipulate that expression to equal secant cosecant. Okay? So don't set them equal to each other and solve. Otherwise, you're just going to get one. Because they're already equal. Okay, you guys are like 2/3 of the way good on your proof. It's just the final few steps. All right, how's it going? Are you guys like really struggling, or you feel like you just need a little more time? You think you got it? You need a hint. Let me see if I can give a hint. Is that how you guys all feel? You guys all need a hint? No. Did you convert everything to sine and cosine?
Yeah.
So you have sine over cosine plus cosine over sine? And then you get a common denominator? Okay, there you go.
Before she said it. That's all I have, but.
And then, oh great, yeah, so now just get a common denominator. Your common denominator should be sine cosine. Yes.
I got to like the part where I know that this equals 1 on top, and then I know you can trans like the other side to 1 over cosine times 1 over sine, which is 1 over cosine. So it, like.
Well, when you're adding, you're going to have sine squared cosine squared on top, or sine squared plus cosine squared on top, and then one denominator cosine sine, or sine cosine.
Yeah.
And you know that 1 over sine is cosecant, 1 over cosine is secant.
Right.
You take it from there?
I figured it out, and I understand how they relate.
It's just the last step that's
I just
incorrect.
don't understand how to, like...
Basically, you don't want to re-separate the fractions.
Oh, okay.
Just keep them together. Yes? Coming.
Oh, I got it! Wait, sorry. That was so loud. I did it.
Yes, perfect. I gave you an imaginary point. Good job.
Hold up. I said that way too loud, way too quickly. Okay, she's like, I have steps, and I'm getting it, and then split it because this, you don't have to split it. What I mean is like, this is the same as that, right? It equals 1. And so when you do that, and then you get
So then once you have that, sine squared plus cosine squared equals
Okay, so few things. Don't set it equal to 0.
Okay.
And you're going to want to, you have some x's and some theta's going. I don't care about that, but
That's what I'm wondering.
Got it. Thank you so much. Don't have that.
But you would make sure you want to wait. Right. What's in it? Okay. This is your second step.
All these things
That's what they look like this tonight.
You want to write it kind of like this, so that it's very clear.
Oh!
Did you get it? Yes.
Okay.
Get it?
Yeah.
So if you're 1 over cosine.
Oh, okay.
All right, ladies, you guys are awesome. Everyone got it? You're not done? Almost everyone got it? How far are you? You're good. Okay, so you're like 2 steps away from it. Sine squared plus cosine squared is 1. All right, ladies, here is the answer. And again, here were my hints that I gave you. Convert to all sines and cosines, get a common denominator. Generally speaking, if you're ever given a trig identity that you really don't know how to start, frequently converting everything to sines and cosines will help cancel things out. Not always, but it's a good place to start if you really don't know what to do first. Okay? All right, so first thing, I converted everything to sines and cosines, and I forgot to write these are the quotient identities. All right, then I got a common denominator. This is 1, and this equals this, and then I drew my box. Okay, a word of caution when writing proofs on the exam. Proofs for this class, I'm not going to be super strict on like format or neatness or whatever, but on the exam, you're probably going to want to first do your proof on scratch paper. That's where you write all your little notes and you kind of have a circular thing going. But on the actual test, you're going to want to write things kind of like this. Or as a paragraph. You could write this equals this because we're using quotient identities. Therefore, you have this once we find a common denominator. You could many people write it as a paragraph proof. But anyway,
Are we gonna have to do proofs on the exam?
no idea. I don't know what's on the exam. I'm just trying to prepare you for anything. Generally, if something like this appears on the exam, what they'll do is they'll say something like, justify this identity, or prove this identity, or what does this equal? Justify your answer. There will be something telling you that you must justify your answer, and points are given for your justification. This would be your justification. All right, any questions on this one? How are you guys feeling about these? You feel like you're little by little getting it? Okay, you guys are doing great.
So I do have one question.
Yes.
So for the 1 over cosine x sine x, does that, like, how do you automatically get it to secant x cosine x?
Oh, because 1 over cosine is secant, 1 over sine is cosecant.
Okay, so you could like separate them? And then
You could separate them. It's not necessary because these are joined. But if you want to.
Okay, cool.
It's an extra step.
Since I was looking at that, I was like, do you separate?
There were some teams that separated them. It's not necessary, but it's perfectly fine.
Okay.
All right, ladies. So, for example number 10, it says, prove the identity cosine t over 1 minus sine t equals 1 plus sine t over cosine t. Do you guys remember what conjugates are?
It's like
Yes. You're basically using the difference of two squares to try to eliminate something. I'm going to give you guys the first step on this one. So this is a new strategy that we haven't done before. Once again, remember you're going to start with the left side. You're going to kind of ignore the right side. But in the back of your mind, you know that's where you're trying to get. Start with this. I'm going to multiply by top and bottom by 1 plus sine of t, because I know this will give me 1 minus sine squared. Why would I want to get 1 minus sine squared on the bottom? Because then it's equal to cosine squared. So here's the Pythagorean identity manipulated so that cosine squared equals 1 minus sine squared. Do you guys feel like you can take it from here?
Yes.
Yeah? Go for it. You guys got this. By the way, just a reminder, please make sure you're checking in with the people at your table. Ask each other questions, help each other out, all right? And if there's a question at your table that no one can answer, call me over. I'm happy to help.
Can you say what was on the side again?
Yes. Here.
Thank you.
Is there a special schedule day? It's a regular one, right? Yeah, it says.
Spanish, it's a Spanish class.
Okay, yeah, it says regular schedule.
No, it's Miss Kim's class.
Yep. Okay.
It's Spanish reading. That class is so hard. Yeah, it's scary. I have 4 APs next year, and I'm not going to
Which one?
chemical, stats, and
So 5?
yes.
So why are you doing that?
They push health, stats, like. But you guys said learning is easy, and then yeah, I know. And I don't have a ASP brings it down. It's 4.7.
Oh, coming. Sorry.
Nice. Mine should be Oh wait, are you No, I don't. Wait, are you standing up? No, I'm not standing up.
So 5 sine squared. You should here. You can also say 5.
And then I have an honor.
Oh, coming.
Yeah, wait, maybe I'll be
Because I knew we have the same because I could have had higher, but I was like, not this game push, so.
Well, they told me English and music too, so I thought I'd cancel.
I don't think English is that bad.
You get a lot of homework?
It's, I mean, it's, you just have to like,
You can.
I prefer to have show breaks. I thought I didn't care about this.
This is less than 2. That means that I can put world
That's okay. It was fun.
Do not take that. Like, I don't know.
I was playing. I was
Don't take the
No, where are you? I'm so in your photo. He's kind of like Mr.
Wait, did you figure it out?
because, like, I feel like I end up every morning like a normal class, and then
Wait, how'd you get your grades?
oh, yeah. Like labs and bio, medicine, bio, water, and it's actually that sounds like maybe I should write that. Bio armor. Well, I was like, I had no idea what like, I didn't go to private school. I went to school, and so everyone was saying like,
Yeah, you figured it out.
where'd you go? I went to Grant, right by Sorry.
Grant? I love Grant.
Because I went to
Did we talk about this already?
It is not right. Aside from the fact that your class is scared. Me too. Yeah. Oh my god. Besides the fact that there's no boys. Like 2 best friends chances to get married. I was all alone.
Yeah, it's awesome. I did my first year there.
Everybody?
No, I can't.
What year? Wait, were you in second grade?
Is there anyone else who needs just like 1 more minute?
Yeah. She did. Sophia had it. She multiplied it.
I see. I would recommend keeping the numerator factor.
We did.
Because then the cosine of the numerator will cancel out one of the cosines in the denominator. So in the end, we'll just need to write the last side.
That's exactly why I did it. I'll feel so sad not to the actors that you really and they were wait, are you I'm doing great. That's my birthday. Only because practices are yeah. Like I could love that. Wait, I hope so. Sorry, you know what? I understand why we're talking because at first I was like, yeah, it's annoying.
All right, ladies, we're going to go over this one. You guys did a great job. Here's the answer. What's going on? There we go. Okay, so the first step, you're going to multiply by the conjugate in order to use the difference of two squares. Shh, ladies. This will give you 1 minus sine squared on the bottom. 1 minus sine squared is equivalent to cosine squared using the Pythagorean identity with some manipulation. You don't need to include the manipulation. This is a very common thing used in proofs. You can just say Pythagorean identity. Then I can cancel out one of the cosines, and I'm left with 1 plus sine over cosine, which is what I was trying to get to. Ta-da! No, I don't think so. Some people write QED, which means something in Latin, but I forget. I like the box better. All right, any questions on this? Okay, I'll leave it up there. Oh, okay, this is a fun one. Okay, anyone need a few more seconds to copy this down? Okay. All right, while people are finishing, if you guys, those of you who are done, if you want to take a look at the exit ticket on the back, prove the identity, and I'm going to tell you what the identity is. If I was to guess, and again, the AP Pre-Cal exam has only been, this is only the second year in existence, so we don't have a lot to go on. I don't think there's going to be an identity this difficult on the exam, but just in case, I wanted to do just one with you guys. Huh?
Will it be on our test?
So you guys have the question bank.
Yeah.
If it's in the question bank, it's a possibility. If it's in the question bank, it is on at least 2 versions of the test. So it depends on which version I randomly select to print. You'll be okay. They're all similar in difficulty. If it's not this problem, it'll be some other difficult problem. Again, if it's in the question bank, I don't remember. All right, ladies. Here is the identity. So this is a strategy you can use when you have an identity that, as hard as you try, you've tried a bunch of things, and for some reason, you just can't figure out how to prove it. You can work it from both sides and then rewrite it. Okay? Let's see here. Okay. We'll do this in steps. See if you can work the numerator, See if you can work the left side of the equation to get cosecant u minus 1. At least this is how I solved it. It's possible there's another way. So, you guys are going to try to solve this first. I used a Pythagorean identity and then a difference of two squares to prove it. There might be other ways. So just prove that identity. It's a cosecant of u. It's the reciprocal of sine. Cosecant u minus 1. You guys got this. But clearly we're not going to finish 5e. And that is okay.
I got it to 1 minus cosecant squared over 1 plus cosecant equals 1 minus cosecant squared, and then that's all I got. I don't know what to do with secant and a tan.
I feel like a shadow
Did you change orbital tan? Oh, that's so smart. I think maybe that was otherwise. Because what's sec?
Oh, that's not a question.
I think you're right.
I don't know what
That's alright. I'm gonna work it.
Yeah? Let's see it.
that makes sense how I wrote it. Oh my god, I wrote it so good. Sorry. So I got to this and then I wrote it down. And then I get cold breeze. And then I wrote that, U plus C squared U minus C.
Her dad's my father.
Oh my god, yes. You're welcome. Oh my god, how old are you? I did it right. Hold up.
She's coming in next week. She's really smart. She's in this class.
I just did. My friend. What did I cross out? And now she's like in Calc 4.
Oh wait, is it Lauren Hill?
That's not after. Well, I know she's also.
Lauren Hill is on.
Okay, I think she's yeah, I don't know. Yeah, we said I have some videos of us being oh my goodness! I remember that. I was like, I'm oxygen.
Oh gosh, I remember that.
Okay.
Alright, how stuck are you guys?
Very stuck. I'm on the step 1.
relative.
Well, I got somewhere.
Yeah.
That looks like he's like,
I think it's some kind of
don't talk to me down there because I don't get it. So I was like,
Great job. Okay, team 4 found a different way to solve it. Different than how I did it.
yeah, and then he whips around like he's been drawing and it's just like a whole thing.
Why'd you do that?
Oh yeah, history teacher likes it. No, they still have to lecture. TV3. I think we're just gonna hang out. But she might
TVQ flash.
That's true.
Alright, ladies, I'm going to go over the first half of this proof. Are there any, does anyone else want me to check it?
Who's the most
Oh,
That's okay, it's fun. People
yeah.
are just it's fun.
My sister had a beef with her math teacher. For no reason. But she looks like a tomato. What grade are you in? My 7th grade. Because he threw our backpacks down the hall because he was mad at us, and this girl clipped in her backpack and her phone was like all. He was kind of mad, and he read us a book about elephants. He was chilling. I think the class like she's our math teacher. COVID broke in. She's our math teacher for 6th, 7th, and 8th. Yeah. So she's stuck with her. She was the 7th grade teacher when I was here.
My friend went ahead. She got so mad because she pulled every paper out. Oh, you can
Team 3 found another way to solve it. We found 3 different ways to solve that.
What?
Let me go over it and then we'll do the next step.
I was saying doing a project and my project was on it was just like write a paragraph or something. And I was like,
All right, ladies, here is the first part of the answer. Oops. Okay, so first thing, cotangent equals cosecant squared minus 1. Sorry, cotangent squared equals cosecant squared minus 1. That is one of the Pythagorean identities. This can be factored using the difference of 2 squares. And then you can cancel these out. Now, team 3 did it differently. They converted everything to sines and cosines, which is a little bit longer but also works. So, amazing job, you guys. And team 4, remind me, you guys multiplied by the conjugate, right? Team 4 multiplied by the conjugate, and they used a completely different Pythagorean identity to achieve the same thing. And your method is actually the same number of steps as mine. Outstanding job, everybody. All right, so I got a really good question. I can't remember. I think it was from this table. The question was, how do you know if you get a proof like this that you're supposed to end here? And the answer is you don't. What you would do if you got this all on your own is you would start from the left side and work the equation until you hit a point where you're like, I have no idea how to continue this proof. And when you hit that point, take the other side and see if you can get, ladies, see if you can get this to equal this, see if you can get this to equal this. And if you can do that, then that's your proof. All right, so the next part of the proof. to make this equal that. And if you can do that, then you have your proof. Yes.
The way that we did it, I feel like
You go last.
In order to prove you
So
can't
bad. Literally, why were the lights on? It was so turn the lights off. It would have been like crammed outside. It's so hot. So what the DJ was playing. It was so loud for no reason.
At Hoka, the songs are so bad. I used to like hit stop every time.
Last year this year.
It's with you.
At Hoka.
I was only inside. I was outside for a little bit. Yeah.
And that's when people started getting requests.
because you didn't.
Yeah. When I was
We used the other side.
Did you?
Yeah.
Okay.
So
where did you
Yeah, where?
So you already did the second one, so you didn't instead of one.
Oh my god.
Basically,
Tell me why.
you can't
Tell
use
me why
both
the
sides
guys do that.
at the same time when
That
you're
is
doing
actually
start with one side and get so whether you start with the right side, you get to the left side, or
Rio, your
left
date.
side, you get to the right side, that's fine.
No, Rio's
In this
probably
case, what I'm doing is I'm saying work both sides to the middle, and then rewrite your whole curve so that it's one.
then now we just do it.
Yeah. In your case here, I think you already did. All this.
Yeah, that's what we
Do you have
So then your proof would be.
Mine's hot.
So this would be the
I'm borrowing a friend.
This would be
So I didn't know.
Well, you know,
one, two, three.
But I mean, I guess I'm literally gonna eat as much food and drink as much soda as I can.
Okay, wait.
To make up for the fact that I paid $88.
wait, so do you have to
So this
the left part of the equation is that, or can we just skip to that part?
I'm just gonna say
I think I got it.
it's enough that it says.
Okay, so I took the left side and I squared everything, and then that got me.
Why did you square?
And then when I squared it, I got
Unfortunately, you can't just square.
I squared the other side too.
There's no other side. You can't work both sides.
Oh.
You can't work. What you're doing, actually, Team 2 did something similar the last time. It works if you're just trying to brainstorm, just trying to see why they're equal, but it wouldn't work for the I would give you points more for the exam. Very nice. Hey ladies, just a reminder, when you're doing a proof, you can't work both sides of the equal sign. Okay, you have to start with the left side and finish with the right side. Although, if you're just brainstorming, you can work both sides just to see how they're equal, but then you'd have to rewrite it in a way that's not using both sides. How are you guys doing with this?
I'm just kidding.
One team got it, but I'm sensing that this one is more difficult. Did you guys all convert to sines and cosines? That's how I did it. You don't have to do it that way. There's probably other ways. That's just the way I did it. Yeah.
I remember thinking about quadratics.
Can we bring them back? Like it was just multiplication quizzes where they're like how fast can you go.
Oh god, we have 1 minute and it's like
Yeah, I was up at that. Like I was so good. Like the average was like 45. I was 450. I was average was like 45. Times 10. Yeah, I got a little that easy. And that's the only time I ever made it. Wait, what's the
I'll be right there, guys. Hold on.
Maggie went to like 5
we went to the same, well, she went to Sony when she was in 3rd grade, we went to the same school.
All right, those of you who are raising your hands, do you guys feel like you got it? We're just going to go over it then, okay? All right, here is the answer. Okay, so starting from this side, the way that I solved it, I converted everything to sines and cosines. Cotangent is cosine over sine. Secant is 1 over cosine. Tangent is sine over cosine. Then I distributed my cosine over sine. The cosines cancel out. I'm left with 1 over sine. This multiplied by this is just 1. Okay? And then 1 over sine is cosecant. So there I have my reciprocal identity. Good for you. Now here's the thing. When you write the final proof, you can't work both sides of the equal sign. So what you're going to want to do is you're going to want to rewrite this in the correct order. So, what you see, we started with the left side. We got this. Then we went to here. Then this was step 4. We went from here to here, here to here, and then we finished with the right side of the equal sign. If you rewrite it, you get this. So this is the proof written from the left side to the right side. The big hurdle is no one would think to go from this step to this step. Like, who would think, oh, from here I'm going to factor out a cosine u over sine u. But that's how you would solve it, or at least one way to solve it. Okay, how do you guys feel about this? Again, I don't think there's going to be one this hard on the AP exam, but what do I know? Yeah. If it's on the question bank, then yes.
Okay.
I don't remember what I put. I made the question banks over the summer. I don't remember what I put there. And all the question banks are stuff from your homework. So if it appears in your homework, then probably. All right, so just a reminder, if you have something like this on the AP exam, if you have something like this in this class, when you're doing the proof, make sure you start with the left side and finish with the right side. Don't treat this like an equation where you're simplifying both sides and trying to solve, okay? You want to write something like this where your first step is the right side, or sorry, the left side, and your last step is the right side. Okay, clearly we are not going to finish the 5E notes. We're going to start it, and let me see. We should just call it. No, I'm sorry. We're a little behind. Let's at least do the first few problems.
Oh my gosh, you're in like 8 minutes, right? Yeah. But I grinded out. I said yesterday.
Okay, real quick. When did we say the test was? The 7th? Okay, ladies, I'm going to push back the test today. Okay. All right. So, let's see here. So, let's see here. So, we're going to do 5E next class. You guys will have the study day on the 7th, and your test will be on the 11th. And I will adjust the dates in Schoology later today. Sure thing. All right, but let's do the first few problems because I don't want to have to postpone another day. All right, does anyone need a few more seconds to copy this down? All right, ladies. Now, in the 5E notes, I don't know why I did this, but there used to be a box at the top with these equations, and I must have accidentally deleted it before I printed these. Okay, so sorry. But these equations are actually necessary to solve the problems. I will zoom in. Here, let's do this. I'll put these up first, and then I'll move it over.
Why is the minus plus sign?
Good question. So if you have sine of u plus v, it's going to be this plus this. If it's u minus v, it's going to be this minus this. For cosine, there is a sign switch. If this is a plus sign, this is going to be a minus sign. If this is a minus sign, this is going to be a plus sign. I just realized my fingers are not showing. If this is a plus sign, this is going to be a minus sign. If this is a minus sign, this is going to be a plus sign. So for sine, it's going to be the same sign. For cosine, there is a sign switch. Well, there's a proof that goes with it, which we will not be doing in the class. But if you want to, these are provable. It's pretty fun. Yeah. Yes. Yes. I'll wait another minute.
Yes.
Okay. Yes. Can I move it over? All right. These equations, I don't think it's as necessary to memorize as the quotient and the Pythagorean identities, but I think it would be really helpful if you have them memorized. A good way of remembering, ladies, a good way of remembering these, just think that sine is going to be sine, cosine, cosine, sine. Cosine is double cosine, double sine. That's how I remembered it when I was in high school, and it stuck. And then tangent, you just have to memorize. You can have a card for the test. I'm saying for the exam. Yes?
Why is the plus or minus upside down?
Okay, so good question. Ladies, I'm going to explain this again. Sine, whatever sign is here is also here. If this is a plus, this is also a plus. If this is a minus, this is also a minus. For cosine, there is a sign switch. What that means is that if this is adding, this is going to be subtracting. If this is subtracting, this is going to be adding. Let me write that here. There's going to be a sign switch. All right, for tangent, the top sign is the same and the bottom sign is switched, which makes sense because tangent is sine over cosine. Yes?
On the bottom where it says like the minus, the number in front of that is
Yes. Is that better? Okay. All right, does anyone need a few more seconds before we try using these equations? Okay. All right, so these are kind of fun to use, I think, but I'm a little weird. It says example number 1, find the exact value of cosine 15 degrees and the exact value of tangent 15 degrees. For some reason, I only found one. I have a way to fix this.
By crossing out the
There we go. Okay, find the exact value of cosine of 15 degrees. So, ladies, does cosine of 15 degrees appear on the unit circle?
No.
No. So what you want to do is you want to create a sum or difference that makes 15 degrees with things that do appear on the unit circle. Now, I used 45 minus 30. But you could use, I don't know, 60 and 45. You could use any of those. And once you simplify it, you'll get the same thing. Okay, so cosine of 45 minus 30, I am going to use this equation here. Cosine of 45, cosine of 30, plus, because of the sign switch, sine of 40, sine of 30. I'll label it again. Sign switch. Now, 45 and 30, those appear on the unit circle. What's cosine of 45? Root 2 over 2. Somebody else, what's cosine of 30? Yes. And what is sine of 45? Root 2 over 2. Sine of 30?
1/2.
1/2. Okay, so there we go. Plug all these in. We end up with a common denominator of 4. Root 3 times root 2 is root 6. Root 2 times 1 is root 2. Ta-da! And now you have the exact value of cosine of 15 degrees, which I know all of you were lying awake at night just wondering, what is cosine of 15 degrees? So that's how you find the exact value of an angle that does not appear on the unit circle. Yes?
Oh, never mind. I was just going to ask if you could do square cosine of 15 and make it cosine, or times 2 and make it cosine of 30, and then you'd get, like, you know, square root of 3 over 2, and then it'd be square root of half of that. But I guess that might not work.
It actually doesn't work. It's a good idea, but the trig function kind of messes that up. If it was just the angle, then of course yes. All right, let's do one more and then we'll call it, okay? I'll just do it as an example. Does anyone need a few more seconds to copy this down? You got it. Yay. I feel like we need more practice with trig identities. Do you guys feel that way too? Yeah. Okay. Then it's good that I delayed the test today. Okay, prove the identities. These are the co-function identities. Oh, a typo. This says cosine, it should say sine. Sorry.
Wait, what?
So A, example number 2A, it says cosine pi over 2 minus x equals cosine of x. That's not the co-function identity. It should say sine. Okay. All right, so prove these identities. First thing I'm going to do is use a cosine sum identity. Ta-da! Any questions on how I got that?
Yes.
Yes?
How did you do that?
It's this one. Oh, this one.
Oh, got it.
Yeah.
I have a question.
Yes.
Can't you just use the co-function idea?
So that's what we're proving. Did you guys remember in geometry when you would prove a theorem? Did anyone ever make the mistake of using the theorem you were trying to prove in the proof? Yeah, and then your teacher said that you can't do that. Yeah, so anytime you're proving a theorem, you can't use the theorem you're proving in your proof. You have to use other theorems. You're trying to prove why that theorem works, so it would be circular reasoning if you were allowed to use the proof. All right, ladies, what's cosine of pi over 2?
1, 0.
0. What's sine of pi over 2?
1.
One.
Negative 1.
Ta-da.
Oh, I ate.
Okay, so when you simplify it, you end up just with sine. So as you can see, we started with the left side, we ended up with the right side, so I get to color in a box. All right, we have time for one more, but I said this would be the last one, so we'll call it here. Okay? You guys did an outstanding job. There's about 3 minutes left in class. You're welcome to grab your cell phones. Shadows, you're welcome to talk to whoever you're following, ask them questions. You can also ask me questions if you have any. Yes. Yeah, of course. Here, let me freeze this and stop recording.